Here are a couple of factoring problems that we're going to factor completely. And factor completely means do every factoring thing you can think of until there's literally nothing left to factor. But that doesn't mean just like shotgun blast your factoring at it and just the first thing that pops into your head, do it. There's a pattern that we follow, and the first thing we do every single time is we look for a greatest common factor. And 6 and 96 do have a greatest common factor. The greatest common factor is 6. They don't both have a variable, so we can't do that. But 6 divided by 96 is 16. 6 times 16 is 96. So greatest common factor is a good place to start. And then when we look here, x squared is a perfect square, and so is 16. So this is a difference of squares. Square root of x squared is x, and the square root of 16 is 4, plus minus, with our greatest common factor in front. So there it is, completely factored. Nothing else to factor there because we just have plain old x. We don't have any x squareds. Okay, so let's go over to the next one. First thing we look for is a GCF, and there's not one. No GCF. Then we want to look and see if there's a shortcut. A shortcut means like, could this possibly be perfect squares? 16y squared is a perfect square. 15 is not. And so we're going to factor by grouping. Factor by grouping means we need to write this so that it has 4 terms. And 4 terms means we take the first term and we multiply by the last term. So 16 times negative 15. Well, let's see. 15 times 15 is 225, and 15 more is 240. So negative 240. Okay, so we're looking for 2 numbers we can multiply to get negative 240. But when we add them, we get 8. First thing that comes to mind for me with 240 is 24 and 10. So 24 times negative 10. But when I add those, I get positive 14. So not those. What about 12? Could I do 12? Oh yeah, 12 and 20. That works. There we go. How about that? Positive 20 and negative 12. So what that means is we're going to take our 8 in the middle and separate it into positive 20 and negative 12. So the 16y squared stays the same. And the minus 15 on the end stays the same. But in the middle, we have positive 20y minus 12y. Actually, probably would have been easier if I'd done minus 12y plus 20y, because then I wouldn't have to factor out a negative, but too late now. It's not like I can just erase. So let's factor by grouping here. 16y squared and 20y has a greatest common factor of 4y, leaving us with a 4y plus 5. And over here, we are, as I said, going to have to factor out a negative. That'd be negative 3, leaving us with, hey, what do you know, 4y plus 5. So our answer is going to be 4y plus 5 and 4y minus 3. And there's our solution to that one. Pretty good. So factor completely just means every factoring technique you know, you're going to apply it until there's nothing left to factor. Start off with the greatest common factor. Then you look for shortcuts. In fact, let me write this down so you can have this in your notes. Is there a greatest common factor? Then you look for shortcuts, which are there any perfect squares? And if there aren't any perfect squares, then you're going to either go straight to 2 parentheses. If it's a simple trinomial, like something that just starts with x squared, or if it's not something that starts with x squared, if it's like a, what do we have here? 16x squared, then you do factor by grouping. Always 100% of the time, is there a greatest common factor? We have to do that first on every factoring problem ever. Check for a greatest common factor first.